everyone, once again welcome to my channel, and today we'll be solving implicit differentiation. We want to find the derivative at x comma y equal to 2 comma 1 if x raised to the power of 4 plus xy plus y raised to the power of 3 minus 11 equals to 0. First thing to do is to write down our x raised to the power of 4 plus xy plus y raised to the power of 3 minus 11 equals to 0. Now we differentiate this implicitly. How do we do that? If you take a look at x raised to the power of 4, there is no y on it, so there is no value for y. So we differentiate. Whenever I differentiate, if there is two different variables x and y in any part, like this is x and y, I will first of all differentiate with respect to x, and then I will write plus, then differentiate with respect to y. And now while I'm differentiating with respect to y, I'm going to add dy dx. But for this case, there is no y, so I will only be able to differentiate with respect to x. So I will have differentiate here to be 4x raised to the power of 4 minus 1. Remember that. Then plus, now differentiate here with respect to x. Differentiate with respect to x is just like the x here is raised to the power 1. So 1 times 1 here is also 1. So it's just like I'm having x raised to the power of 1 minus 1 times 1 here, which is nothing. So then y. Then also plus, I will not differentiate with. Now the reason why I will not differentiate with respect to y here, because there is no y here. So we only respect to x. But for here we differentiate with respect to x. Then now we differentiate with respect to y. If I differentiate with respect to y here, I'll be having x, then y raised to the power of 1 minus 1. Then remember, whenever you differentiate with respect to y, you add what? Dy all over dx. Now we'll continue. Plus, now over here we have only y raised to the power 3. So I differentiate with respect to y, so it should be 3y. So we have 3y raised to the power of 3. Then we add as usual dy over dx. Remember, if when you differentiate any constant, we get to what? 0 is equal to 0. Now from here we can now have that 4x raised to the power of 3 plus, this is automatically x raised to the power of 0, and x raised to the power of 0 is what? 1. So 1 times y gives us y, plus x, this is y raised to the power of 0. Y raised to the power of 0 is 1. X times 1x, then x dy dx, then plus 3y, this is 3 minus 1, sorry for that. So 3 minus 1 will give us 2. So 3y raised to the power of 2, because we are differentiating y raised to the power of 3. Remember, we have to subtract 1 from the power. So we have this dy over dx equal to what? 0. Now we collect like terms. The one not having dy dx straight to that side, the one having dy dx to leave it here. We have x dy over dx plus 3y square dy over dx is now equal to minus 4x cubed plus minus y. Remember, this is plus, so if it comes over change to minus, this is plus, comes over change to minus. So now we collect like terms, we factorize. We have x plus 3y square is now equal to minus 4x cubed minus y. So from there we have that we divide both sides by x plus 3y square. So we have that dy over dx, x plus 3y square all over x plus 3y square is equals to minus 4x cubed minus y all over x plus 3y square. This will cancel like this, making our dy over dx to be equal to minus 4x cubed minus y all over x plus 3y square. Now from here, now we will now go on to replace. So we have that x comma y is equals to 2 comma 1. that, we'll now have that this dy dx will now be equal to minus 4 2 raised to the power of 3 minus 1, because x is 2 and y is 1, all over 2 plus 3 1. From here now we can see that our dy dx is now equal to minus 4 times 8 minus 1 all over 2 plus 3 times 1. So this will now give us equal to minus 4 times 8 should give us minus 32 minus 1 all over 2 plus 3, which is now equal to minus 33 over 5. This becomes our answer. Thank you for watching. Please ensure you subscribe. Thank you.